In Java, when you want to repeat a certain execution of a statement, there are two ways to do it. You can do recursion or you can do iteration. Iteration we'll get to soon. That uses a while statement. It'll continue executing a statement while a certain condition is true, or you could have a for loop. It'll tell you to execute a certain statement a certain number of times. Recursion is a different way of doing it. It's supposedly the way our brains think. But when you're reading code, sometimes it's a little bit strange to get into that mode to get your brain thinking that way. So we're going to look at it a little bit, and then you're going to play with it a little bit. Okay, so we'll look at some simple examples. So recursion is basically when a method invokes itself. It calls itself, and there has to be a way to stop the recursion, because if you have a function calling itself, at some point you have to tell it to stop calling itself. Otherwise, you have the same thing as when you hold your you're doing a selfie in a mirror. You'll see endless iterations getting smaller and smaller of yourself. It's kind of the same thing, but you have to make it stop somewhere. Otherwise, it'll go on forever, and it can't do that. You don't want your program not to stop. So anyway, that's why we're saying if there's no base case, or if for some reason the base case is never reached based on your logic, you get a Stack Overflow error. There's a website called Stack Overflow, which is basically for people who has all kinds of questions about any kind of computer science stuff. If you're coding in C, C++, Python, Java, anything, even Linux, whatever, that website is named after this error because it's a very common error. Okay, so let's just look at a simple example. Oh, by the way, I should explain what a stack is. A stack is a data structure. Think of it like a stack of paper on your table, maybe on your desk. You have some things that you have to do. You keep putting them in a pile, or you keep putting them in a stack. When you start working on your stack, you usually take what's on the top of the stack. So that's actually called a last in, first out. The last thing on the pile will be the first thing that you act on when you're working on the stack of paper on your desk. That's called a LIFO, last in, first out. So this is very similar, but it's a function call or a method call stack. So the first time I call the method countdown, well, actually the first thing I'm going to do is call main. So this is the stack diagram that goes with this case. So I don't show main here because we know that main is always the first thing that's invoked. So in our case, we're assuming that we called countdown. That's the method here that we're calling. We called it with a value of 3, an argument of 3. So an integer 3, it's expecting an integer. So what I'll do the first time I call it is, here's where my first call is in the stack diagram. I called countdown with a value of n equals 3. So I come into countdown. N is not 0, so I don't do this. Instead, I do this. N is not 0. I continue the countdown with a different value. So the first thing I'm going to do is print out 3, because that's what I was called with. And now I do countdown at n minus 1, meaning I'm going to do a countdown with an argument of 2. So here's my stack diagram. Main is still active. I didn't finish it. This invocation of countdown is still active. I didn't finish it. I'm actually right here in it. I'm right at this point. I didn't get to the end down here. I'm stuck here. So now I'm invoking it with countdown 2. 3 minus 1 is 2. So here I am. So I'll come back into countdown. If n is 0, I blast off. Nope, it's not 0. So now I'm printing out 2. So I did my countdown so far. I printed 3. I printed 2. Now I'm going to call countdown with n equals 1. So so now my stack diagram shows main is still active. This invocation and this invocation of countdown is active with n is 3 and n is 2 because remember I'm stuck here in both of those. I didn't get to the end. Now I do countdown n equals 1. Come back up here. Countdown 1. Nope, n's not 0. So now I'm going to print out the argument n. So I printed out 3, 2, 1 so far. Now I'm calling countdown with n minus 1. Well, 1 minus 1 is 0. So again, here's my stack diagram. These are all still active. Now I'm calling countdown with n equals 0. So I come back up here, countdown 0. Oh, n is 0, so I'm going to print out blast off. So I've printed out 3, 2, 1, blast off. Now I'm done. So I end down here. I'm not calling countdown again. So that means when I exit, I did this part of the branch. I didn't execute this because that's the else. I end here. That means this one is complete. The countdown n equals 0 invocation is complete. That'll disappear. So now I go back up to the one I previously called. I return to the spot right after the statement where I called countdown, which was right here. This was where I called countdown n equals 0. So now I'm back in the invocation of countdown n equals 1. There's nothing to execute here, nothing to execute here. I'm done with countdown. This one disappears. Now I'm back up to countdown n equals 2 right after where I called it. This is where I called countdown n equals 2. I'm at this statement, there's nothing to do. This statement, there's nothing to do. Now countdown n equals 2 ends. Now I'm bumping back up into the stack, countdown n equals 3. That's still active. Remember, I never finished it. I stopped here and waited for the other countdowns to finish. So now I'm at countdown n equals 3. Nothing to do here, nothing to do here. That disappears. I go back to main and I'm done. So it will actually print out 3, 2, 1, and it actually won't even print out 0, 3, 2, 1, and then blast off. Now, interestingly, if I switched these two statements, if I switched countdown and the printout, I would get my values in reverse order. That would actually be a count up. We're going to look at that when we get to the code samples. I'm leaving you some code samples to play with, but first we'll look at the countdown and the count up. So here's the blast off class that does the countdown and the count up. It also has something called display binary, but we're going to hold on to that. The method is still here, but we're not going to call it till we talk about binary numbers in the next lesson, so just ignore that for now. Okay, so I come in, I'm going to do a countdown. Remember, all countdown does is it recursively calls itself with 1 minus the integer that you gave it. And when you get to 0, when you call the countdown 0, that's when you blast off. And then you repeatedly return to all the previously invoked countdown methods in the stack and then print out whatever number you have. So it'll print out the 3, 2, 1, and 0. Okay, so one thing we also have to look at is this count up function. How is it different than count down? So if I call count up 3, I'm calling with an argument of 3. So first time I come in, I do count up 3. Okay, n is not 0, so I'm not ready to blast off. But I'm going to call count up n minus 1. So I'll call count up with n2, but I didn't print out 3 yet. I didn't print out what I called it with yet. I'm printing that out after I return. So I'll call count up 3. I'll call count up 2. I'll go up here. I'll call count up 1. I'll go up here. I'll call count up 0, which makes me n. So I'll see a blast off. And then I'll see when I return here, I will have, remember, I'm returning up to count up equals 1. Or sorry, with an argument of n equals 1. I will print out the 1, go here, there's nothing to do, here nothing to do, I end. So now, remember the stack trace, or the stack method called stack has, now count up 2 is still valid. It's still in operation, it's still in the middle of its invocation, but it's right at this point. So count up 2 will then be returned to, and the first thing it says to do here is the statement right after what I called count up. It'll say, call it with n equals 2, call print out. So I'm going to print out, or sorry, println, I'm going to print out 2. I fall off here, but there's nothing else to do. I'm done with count up 2, that exits. I bop back up on the stack trace up to count up 3. I don't do this because n's not 1. I finish here. Remember, this is where I called it. When I return from that, I will call println, which will print out the 3, and so when I'm done, so actually 3 was where I called it, so now the next thing I have to do is go back up to main, and main is just, there's nothing else to do here because this is commented out. I end here, I'm done. So that it's a little bit of a strange concept, but we'll work on it a little bit and you'll play around with it. It'll make a little more sense, but I just want you to see what happens when we run it. So I count it, I do a countdown. First thing I do is call countdown. 3, 2, 1, blast off, count up, blast off, 1, 2, 3. We'll go over more examples of that so you understand why they go in whatever direction they are. Why one goes up, one goes down.